Thanks to the organizers for putting together such a great program, and I'm humbled by the invitation. I will be talking about a joint project with Laurent Mathevet, and it is titled Organized Information Transmission. I'm happy to receive questions, but depending on how many I receive during the talk, hopefully I'll be able to take some of that, 5 minutes at the end back towards the talk. Otherwise, I won't be able to go through everything. But it's an equilibrium thing, so I'm fine to handle things as they happen. Okay, so information is often transmitted in horizontal or vertical ways, and I will be increasingly clear about what I mean by that. So horizontal transmission refers to informing a group of listeners symmetrically and simultaneously. Examples include academic seminars, talks such as this one, board meetings, press conferences, etc. And the benefit for why a sender might want to do this is that transmitting the same piece of information to a group of people at the same time is less costly than transmitting it to each one individually, where the sender has to maintain separate channels of communication. On the other hand, vertical transmission refers to information passed down sequentially and potentially asymmetrically from one individual to another. So think, for example, about hierarchical communication in organizations where we have directors communicating with managers, managers communicating with supervisors, and supervisors communicating with workers. Or viral marketing is another example among potentially others that exist in real life. So in this case, a sender might benefit from delegating the transmission to the players themselves if, of course, truthful communication incentives are satisfied, and of course, if there is an informativeness hierarchy embedded in the information structure. But this will be kind of the nature of vertical transmission. So what we do in this paper, we introduce a general way, a general taxonomy of how we should be thinking about categorizing information structure with respect to the horizontal and vertical opportunities which they provide. So the opportunities for horizontal and vertical transmission. And in particular, we will focus, this taxonomy is general and it can categorize all information structures. And in particular, we will focus on two classes of these information structures, which would serve as natural proofs of concept for why this question might be operationalizable and interesting. So those two classes, for them, we'll categorize the outcomes they implement in general finite environments, which will provide an organizational perspective on incomplete information and its implied consequences on the distributions over actions and states that can be implemented under those information structures. And also the constraints, our characterization constraints will be, can be used in the context of constraint information design, where an information designer doesn't have all information structures to choose from, but perhaps wants to restrict himself to horizontal or vertical transmission possibilities. And we will also show for those two classes of information structures that they're optimal in binary action environments with complementarities. We will identify two sufficient conditions which are nested, which make horizontal and vertical transmission without loss in those environments. So in comparison, direct information structures which invoke the revelation principle and make incentive compatible action recommendations do not constrain information horizontally or vertically, because those information structures may require private communication to each of the players involved in a strategic interaction and would not allow communicating with a group, a subgroup of those and transmitting information in that way horizontally, or may not have a hierarchical ordering of informedness and therefore might not allow vertical transmission between the players. So this makes direct information structure very difficult to implement in reality. And a quote which kind of describes our motivation is that the quote by Van Zandt, which is that the revelation principle in mechanism design is both a blessing and a curse. We all know why it is a blessing, but it is a curse because direct mechanisms provide such an unrealistic picture of decision-making in organizations. In our case, the argument will be that direct information structures provide an unrealistic picture of communication or information transmission in organizations and other real-life settings. Okay, very briefly, this is a non-exhaustive list of the literature, but I just wanted to flag what the relationship of our work is to existing work in the literature. So first, our optimality results, not our characterization results, but our optimality results will speak to binary action supermodular games, which is the first bullet point here in the information design category. So we will show that our information structures are optimal in those environments. And I will be talking about information structures that are not direct. So they're indirect, but they're indirect not because we focus on adversarial equilibrium selection, which tends to be the reason why indirect information structures are considered typically in the literature. So our connection to the adversarial equilibrium selection part of the literature is that we will be talking about indirect information structures, but the motivation for that comes not from adversarial equilibrium selection. We will have a preferential equilibrium selection when we talk about optimality for the designer, but rather it will come from the epistemic properties of these special families of information structures that we're focusing on. And those epistemic properties will require that you're not only given an action recommendation, but you're given more than that. In terms of our characterizations will also be related to solution concepts for games with incomplete information, and naturally to the literature on communication in organizations. Now, the preliminaries, the model is quite standard. So we have a finite set of players, an uncertain state of the world omega, which is drawn from a finite set and according to a common prior mu of that set. Payoffs depend on the action profile and the state of the world. Only for our optimality results, we will restrict attention to binary actions, and we will also normalize the payoff associated with the zero action to zero. Now, the object of our characterizations will be the outcome that can be implemented with these classes through horizontal and vertical transmission. So those outcomes are the outcome distributions over action profiles and states. And in particular, we will want to contrast what can be implemented with our special classes of information structures relative to what can be implemented with all information structures. And we know that what can be implemented with all information structures, the outcome distribution, that is the set of base correlated equilibria due to Bergman and Morris. So I'm just gonna quickly, I'm sure this is common knowledge in this group, but I'm just gonna, for the purpose of completeness, I'm just gonna say that a distribution is a Bayes correlated equilibrium if it obeys the prior, that is, it is consistent with the prior, and in addition, it satisfies the obedience constraints for all players and actions. Now, an information structure, again, just for completeness, the definition is very standard, consists of a set of signal profiles and a set of distributions over signal profiles conditional on states, one for each possible realization of the state. Now we say that an outcome distribution is implemented by an information structure if there is a pure strategy Bayes-Nash equilibrium such that when we sum across all the signals that give rise to the same equilibrium action and we use the prior to update conditional on each state, we will back out the same distribution over actions and states as P. The restriction to pure strategies is with loss. However, that allows us to capture quite a bit of structure while maintaining quite a bit of generality at the same time. But unlike the result of Bergman and Morris, where there is always a direct information structure which implements any distribution over actions and states, here the restriction to pure strategies is with loss of generality. Okay. Now, in order to talk about horizontal and vertical transmission, I need to introduce a bit more language about informedness. And I'm going to define a very strong notion of informedness. So let mu I conditional on SI denote I's belief about the state and about everybody else's signals. We will say that I is weakly more informed than J at S if there is nothing that J knows at S, not even his own signal as J, that I does not know, and that would lead to I up changing his beliefs, both about the state or about the other people or the other players' actions, the other players' signals. So it's a very strong notion of informedness, not only Blackwell informedness, but also you know everything about everybody else that player J knows, including player J's own private signal. We say that I and J are equally informed if they're weakly more informed than each other. Now, we needed this definition of informedness in order to be able to formalize what we mean by horizontal and vertical transmission. We say that horizontal transmission to I and J at signal profile S is possible if I and J are equally informed at that signal profile S. And we say that vertical transmission from I to J at S is possible if I is weakly more informed than J. And there is also additionally communication incentives, which I will speak to briefly. Now, given those two things, you can see how all information structures can be classified depending on the amount of horizontal and vertical transmission they allow at any S. In one extreme would be public information, where everything can be horizontally transmitted to everyone at all signals. At the other extreme, there might be an information structure that allows no private communication between any player at any signal. So all information structures can be categorized into this set of organized information structures according to this relationship. But we want to focus in this paper on two specific classes of information structures. And we will call them single meeting schemes, which will illustrate kind of a limiting case of horizontal transmission, and delegated hierarchies, which will illustrate a limiting case of vertical transmission. So next, I'm going to proceed with the characterizations for each of those two classes of information structures. And after that, I'm going to tell you, if I have time, about the optimality results for those two classes of information structures. Now is a good time to take any questions, if there are any. No? Okay, good. So first, the characterization for single meeting schemes. First, I have to tell you what we mean by single meeting schemes. And if we look around, we will see that a lot of the times, well, first of all, there is a lot of meetings that take place all the time in departments, in organizations, perhaps too many at some points. In principle, what is common for meetings is that the content of a meeting is common knowledge among the participants. And also, if you are in a meeting, you know who is not at a meeting, and therefore who has not observed that information. So in single meeting schemes, there is only one meeting ever taking place. So the participants at that meeting can deduce that the non-participants are uninformed about what has happened. And the non-participants do not know which meeting has taken place. So the formal definition is that an information structure is a single meeting scheme if for each signal profile S, signal realization profile S, there exists a subgroup of players MS, and at most one signal realization per player, SI tilde, such that if I is in the set MS, then I is weakly more informed than all other players. So I knows everything that all other players know. And if I is not in a meeting given a signal profile, then he has observed the same signal realization, the non-invitation to a meeting. So there is only one non-invitation to a meeting there, and therefore if you're not invited to any meeting, that is the signal that you observe. So what is embedded in this definition is that in single meetings, communication is information is communicated publicly to a subset of players. So in a way, it's local common knowledge or local public information. And if two players are in a meeting, then they're equally informed to each other, because each player is weakly more informed than everybody else if he's in a meeting. So those that are in a meeting are equally informed. Non-participation may carry different information about the state and about other players' beliefs. So if two players are not invited to a meeting, they may still have different hierarchies of beliefs. And also there are many possible meetings ex ante, because there is an information structure is a distribution over possible signal realizations, but only one meeting ever takes place depending on the realized signal S. And so what strategic outcomes can emerge in a game where incomplete information is described by single meeting schemes? Either players themselves organize to receive information in meetings, or they're organized by somebody else. The question is, what strategic outcomes can be generated if we restrict attention to such shape of the informational environment? And the answer to that is our theorem 1, which says that an outcome distribution P, which is a Bayes correlated equilibrium, can be implemented by a single meeting scheme if for all but one action profile, and that one action profile is AI tilde, there is stricter obedience constraints that hold. So let me not call them obedience, let me call them just constraints, because they're stronger than the obedience constraint. The obedience constraint would be summing this inequality across all action profiles, A minus I. But here we are requiring that even if you knew what the other player's actions are, you would still play action AI. And you may have only one action AI tilde where the standard BCE constraint holds, which is more relaxed than this. But for all other action profiles, this stricter constraint holds. So naturally, we will have a subset of the BCE set that is implementable through single meeting schemes. And we have used the battle of the sexes on a complete information game, just because of the dimensionality of the graphs. But on the right, we have the set of correlated equilibria, which corresponds to the set of Bayes correlated equilibrium when we would have incomplete information. And on the right is the set of single meeting schemes. So the single meeting schemes is a union of faces of the Bayes correlated equilibrium set in this particular example. And what is common to all examples is the public information structures are at the intersection of all faces of the single meeting schemes. Each face represents taking one particular action profile as A tilde and computing the possible distributions that could be associated with that. That is, what action recommendation profile do you want to give to the players who are not in a meeting? And that determines that the stronger inequalities need to hold for all the other action profiles. So the randomization between the two Nash equilibria, which is this line here at the base of the two triangles, is, as I said, at the intersection of the two sets. And also, as I said, each one of these spaces you can compute by choosing a different A tilde as the recommendations that players receive when they're not in a meeting. Okay, yeah.
5 minutes.
Okay. So let me give you the characterization of delegated hierarchies. So there are two ingredients to delegation. To be able to vertically transmit information to one another, players must be ranked in terms of informedness, and So therefore, we must have an information hierarchy where there is a total order such that for each S, the same order of players means that each player, each predecessor is more informed about everything than the successor. And to be willing to transfer information to one another truthfully, communication incentives need to be satisfied. So delegated hierarchies, what they allow the sender to do is to communicate only with the most informed player at the top of the hierarchy. And from there on, what the implicit story is that there is a sequential cheap talk game beginning with that most informed player, in which each player receives information, becomes an informed receiver for the subsequent player, gives him the relevant part of the signal according to what he's supposed to tell him, and chooses himself an action strategically. So therefore, deviation incentives are quite involved in this sequential cheap talk game. In equilibrium, there has to be no profitable deviation from truthful information transmission and from equilibrium action. Now, the strategic outcomes, again, that can emerge in a game where incomplete information is described by delegated hierarchies. Here, the constraints are as follows. Any distribution which is consistent with the prior. In the previous characterization, we didn't need this condition because we embedded it by saying that P is a Bayes correlated equilibrium. But here we will say that any P that is consistent with the prior, and for all players, the following constraint is satisfied. Knowing the actions of your successors, that is of everybody else that is less informed, those are these actions here, that action profile. You don't have an incentive to deviate in own action and in report to all the other players after you, because by deviating, you can change the equilibrium play of everybody else that comes after you that is less informed in the hierarchy, as long as that action profile that you're deviating to, of course, occurs with positive probability in the information structure. So these constraints are again stronger than the BC constraints, because the BC constraints will be summing in addition across all of these action profiles, but they are the constraints that are necessary to guarantee that a delegated hierarchy where a sender communicates with the most informed guy and then information truthfully gets transmitted down the hierarchy in an intended way happens. So in the battle of the sexes, only the two Nash equilibria, not even their randomizations, can be implemented by a delegated hierarchy. The fact that here the set of delegated hierarchies is a subset of single meeting scheme is not a generalizable result. It just happens for this game. And on optimality, I am running out of time. I just wanted to know, to let you know that single meeting schemes and delegated hierarchies are optimal. The single meeting schemes are optimal when we assume a monotone designer whose objective is increasing in the action profiles. And if also there is the UIs, the payoffs are weakly increasing in the opponent's action profiles, then we have the single meeting schemes are optimal for quite a wide range of objectives that are in the cone of all monotone functions and utility functions. Whereas if we, in addition, assume that B is supermodular, like a stronger concept of complementarity, then we will get that delegated hierarchies are optimal for such designers. And yep, that is my talk. I'm happy to receive questions.
Thank you, Ina. Any questions?
So I had a question. Are there any other indirect information structures which would be particularly interesting to analyze? And when I say particularly interesting, I mean either for which you could get a tractable characterization result or for which you could demonstrate an optimality in a narrow class of games.
So we do have in the extension, we talk about many simultaneous meetings. So more than one simultaneous meeting, which is a natural extension of single meetings. Of course, by the time you get to as many meetings as players, you don't have any loss of generality. But indeed, we can do the characterizations for any m less than or equal to n. And also we have random delegated hierarchies, which allows for changing the hierarchy depending on the realized state, the realized signal. So here in delegated hierarchies, I'm keeping the hierarchy the same because, for example, in the military, the hierarchy is fixed for, or in an organization, the hierarchy may be fixed. But you might think of a firm that, where information flows in different directions depending on what kind of information it is, for example. And there we can have a random delegated hierarchy where we allow the informedness to change with the signal, and for that we can characterize as well. In terms of optimality, we have not thought about it in more detail, but really any combination might be characterizable. It's just that it's not going to look very neat. For some people already this might not look neat, so I'm not sure what the metric is there.
Thank you.
I have a quick follow-up question. So I think one structure that will be interesting to me is just the hierarchy. So not a delegated hierarchy, but I guess I would call it a hierarchy where you just drop the IC constraints. You just tell someone, this is the recommendation, and you must pass this information to the next guy. And it seems like it will be a more flexible class. So maybe even proving optimality will be easier or will just require weaker conditions. Have you thought about that?
Yes, this is actually where we started. And I think that it was because we kind of got in the binary action environment, we got the transmission for free. The particular environment that we have, we got that for free. And that's why we also said, by the way, this is robust to strategic communication incentives. But you're right that one could have this characterization without the deviation in message. And that will be, of course, a less strict constraint, and therefore it will be a superset of what we are characterizing. Yeah. We thought we were making it more applicable to real life, but maybe, yeah, maybe not.
Okay.
And may I?
Yeah, sure.
May I ask about the connection, if any, to Jacopo and Simone's paper, because sounds related.
Yes. So if I remember correctly, there it is the transmission happens automatically. There is no strategic aspect to that transmission, right? So in a sense, if I remember correctly, single meeting schemes could capture their environment because everything is shared to everyone that is connected. But delegated hierarchies, so in their setting, first of all, the transmission is immediate and it is complete. There is no potential for partial transmission the way we have with the hierarchies. Because in the hierarchies, the more informed player does not transmit everything to the less informed one, but only the relevant portion of the action profile recommendation. So in a sense, they have non-strategic and full transmission, whereas we allow for strategic and partial transmission. Does that?
Yeah, but yeah, so when I look at the single meeting result, it feels more similar to
that's right. So the single meeting schemes have a flavor of that. I remember our email exchanges, and I think that we found some discrepancy there as well, but unfortunately my memory betrays me at the moment.
No, thank you.